We'll go first. Thank you.
Thanks, Randy.
Sure.
Good morning. It's great to be back here. I met Randy at the Annapolis Boat Show this fall, and he got very interested in introducing you guys to this new technology that we're rolling out throughout the U.S. and the world. Let me introduce myself. I'm Miguel Guerrerio. I'm the founder and Chief Executive Officer of BlueGas Marine Corporation. We are a marine company based in North Carolina. Our headquarters are just outside of Raleigh. And this is new technology that we started in 2012, but it's only available to the public 2 years ago. In 2015, we started rolling it out. It's obviously patented, and we're the world leaders in powering vessels with natural gas. It's easy to say we're the world leaders because there is no other hybrid technology out there like ours. We are deploying this in several customers in the U.S. and also overseas, and I have some cool projects to show you. Feel free to interrupt at any time. I like very interactive presentations. This is I'm here for you. Raise your hand at any time, and we'll go there. So let's see what I have in store for you guys today. I'll tell you more about why we started the company. What is the essence and what problems we solve. I'll show you what products we have commercially available, and then we're going to dive into the actual onboard fueling systems, and I'll explain the advantages and the drawbacks of using the technology, and then we're going to go into what does this really mean for a boat while it's in operation. Then I'm going to show you some real-life examples of what it does for the fuel efficiency and for the fuel consumption of a vessel. I'll have some interesting market data to show you. Cars versus boats. It's always a lot of fun for us boating people to see how much more fuel we consume, then I'm going to show you other products that we make in the fueling station side, because if you are powering boats with natural gas, you need a way to fill them up, and so we're on that market as well. And then I have catered the presentation to you as well. There are some income opportunities for you as well to introduce the technology to others. So we're going to talk about those as well. So let's get started. BlueGas Marine was started with a premise that operating marine vessels is a costly proposition. Not only are marine grade fuels much more expensive than land fuels, boats spend a phenomenal amount of fuel, and so it makes the operation of those vessels expensive when compared to on-land vehicles. So if you look at not 60 years ago, but 30 years ago, even while we were importing natural gas in the U.S., there were the first buses and trucks started running on natural gas. Even with the imported fuel, it was always 1.5 times cheaper to run them than on gasoline and diesel. So we have started thinking, why have we not seen this in boats ever before? And we found out what the issues were. Well, technology was not available. There were no devices to make current existing engines to run on natural gas. So we made it our business to create that technology, and for the last 2 years, we started rolling it out throughout the US and the world. So the economic factor is always the driving force behind making people do something. However, we are in a period of our history as a nation and as the world, where we're everly growing conscious about being stewards of the environment and introducing technologies that help clean up things. So here's an example of a technology that it pays for itself very quickly, and I'll show you some payback scenarios. But it's also extremely clean, and so it provides a green fueling alternative that was not available before. And I say alternative, but it will very quickly, for certain operators, become the primary means of fuel, with the current fuels being the backup fuel or the secondary fuel, as I'll show you. So let's say, for instance, comparative to gasoline, marine grade ethanol free gasoline, $3.75 now. It's the average on the East Coast, especially if you go to the heavy boating states, going to the Southeast and to the Gulf, and also on the West Coast. We have, outside of the commercial use, less use of recreational boats, if you will, during the cold months in the Mid-Atlantic and Northeast. For obvious reasons, it's cold. It's not fun to be out there. So what does our technology do? So first of all, generically speaking, we make natural gas fuel systems for onboard vessels, and we also make the fuel stations that go on land or mobile, so we can fill up those vessels. From small boats to large ships, we do it all. We use two storage technologies to store the gas on board, and according to the boat's usage, we pick one or the other, the one that makes most economic sense. They are compressed natural gas and liquefied natural gas, and each has its own merits. So what does this do for a boat after it's installed? Well, first of all, it's an add-on product that you can add to any existing engine. And there are many engines that are we've made it compatible with already. So it takes us only a couple of weeks to produce a system for those engines. Others, because we have so many customers, we have not made systems for every engine, obviously, but it is compatible with 90% of the engines in the market as it currently stands. And if it's not, we'll make it so in just a few months. Let's talk about compressed natural gas. 1 gallon of gasoline right now at the wholesale level, what the gas stations buy it, it's $2 per gallon. The same amount of natural gas in the wholesale that could be purchased by those marinas as well that dispense fuel is 25 cents. Huge disparity of almost 10 times, and that's because we are producing country. Even if we weren't, it would still be at least 50% cheaper. It has always been for the past 20 years and will continue in the future. But now we're seeing something very interesting, which is the price of traditional fuels continues to increase. We are in an artificial period of low prices, and it's not sustainable. BP and all the other major oil companies know that, and the prices are increasing now. And the price of natural gas is decreasing because there are more and more producers around the world. If I were to ask you names of oil companies, you could probably name BP, Shell. Well, probably a lot of you don't know that, for instance, Shell makes more than half of its money from natural gas production, not from traditional fuels production. And the same is the case with ExxonMobil, the largest natural gas producer in the world. The reason is all of these big companies have figured out that the use of current traditional fuels is limited with ever-increasing pollution standards. So also, it's much cheaper to produce natural gas than traditional oil, and it's scarce. So they have to find it where they can find it around the world. Natural gas is abundant. It exists everywhere. Pretty much every continent has got almost unlimited quantities. So that's the reason why we are introducing natural gas to the marine environment. It is a great substitute fuel, and let's see why. So we already know that it's a whole lot cheaper, but also it's very clean. So let's see how clean. Compared to gasoline, it reduces pollution by 70%. That's combined air pollution, emissions, and water pollution, which there's almost eliminated the water pollution. Compared to diesel, it's actually more than 90% pollution reduction. So you see all the smog go away. On the gasoline, there's absolutely no, on gasoline engines, there's no smoke, no carbon deposits. Nitrogen oxides reduced by 90%. Carbon monoxide reduced by 90%. Sulfur oxides, what burns your lungs when you breathe gasoline exhaust, it's gone because there is no sulfur in natural gas. And the carbon emissions are reduced, which is the greenhouse gas that everyone is worried about for climate change. And smoke eliminated. Exhaust odor gone. So very enjoyable on the recreational side. You'll no longer smell your engine. And also there's carcinogenic exhaust from gasoline and diesel, benzene, that is completely eliminated when the boat is running on pure natural gas. But that's not the only form that you can run. So because we eliminate all of those pollutants, which are the leading pollutants out there, your engine loves it. There is no carbon deposits. The engine lasts longer because it heats less. The combustion is more gentle and the engine runs cooler. No carbon deposits means that there is no grit for your parts to rub into, and so they don't get loose as fast. And because of all of that, we say it's green for the wallet and green for the environment. And that's why we put that in there. For a professional operator, there's a 6 months to a year payback after you put this system there from the savings of the fuel alone.
Excuse me, and also I would consider as well is that fewer oil changes.
That is correct. And the reason why we don't talk about the benefits of maintenance, it's because of our agreement with the engine manufacturers that we don't want to change their written maintenance charts. But if you run the boat primarily on natural gas or a combination of natural gas and the traditional fuel, what you're going to see is that the oil comes out clean at the maintenance intervals that the manufacturer asks you to do it. So, and the reason why we're not saying that just yet is we want folks to keep their warranty intact. If they start changing things, you know, welcome to do it after your 1 year warranty is gone. But until then, keep doing it like that, so they don't have an excuse.
You can change your oil every 40 to 50 hours. Now you can change it at 150 to 200.
That's right. You can, yes. So let's talk about our products that cater to the gasoline market. We also have them for the diesel market. So for our core products are onboard fuel systems. So those go into propulsion engines. You can see Suzuki outboard here, Yamaha outboards, Mercury. We have done all of those outboards. We actually, you can see on the brochures that I left at your desk, the big boat there. That was a 33-footer Intrepid with two 300 horsepower Mercury Verados. We actually started this on the Yamaha engines because they are the dominant gasoline engine seller in the United States. But then we expanded very quickly to Mercury and Suzuki. You can also see there's the black engine is a Mercruiser inboard or outboard stern drive engine, depending on the existing both configurations. So that works there too. It works on the power generators as well. The marine generators, they're gasoline powered. It's actually fairly easy, even easier for those because of the constant RPMs that they run at. So we do this for gasoline engines. And if you don't see your engine here, ask me about it, and there's a likelihood that it is. There is only one engine brand that there will be a long time before we'll go onto it, and that's the two-stroke Evinrude, even with the new technology. So we primarily cater to electronically fuel-injected systems that are four-stroke. Yes?
In regards to the Mercruiser up there, with a CAT engine, how would that work as far as the sensors?
Like CAT with the...
with the catalyst in the riser there?
Yeah, it works. It works the same.
It doesn't set off any codes because you wouldn't have the difference in the two sensors.
Yeah, there's we accommodate that as well. You know,
pretty much eliminate it at that point because it's not a dirty version anyway.
Yes, but while it's under warranty, we can't bypass the catalyst. What we can tell you is that the catalysts are there, obviously, to reduce pollution. But after you're running with the natural gas, that pollution is almost eliminated, so you don't need them. However, for warranty, they still have to be there for emissions. You, as the operator, outside of the warranty period, you could remove them, and we can customize an exit or a bypass of the exhaust for that. And the reason why you would want to do that is catalysts rob the engine of power. We can see that natural gas cars and trucks get an 8% better fuel efficiency while running on natural gas, while on engines on the marine side without a catalytic converter, we're able to increase efficiency 35 to 50%. And that's all of that is the catalytic converter. Not all of it, but the majority of it, the catalytic converter robbing a lot of that power from the engine. Yes, sir.
You said earlier that it doesn't run as hot. Does that mean you lose some power, or you still maintain the same power?
No, we match the power. Yeah, so I'm going to show it to you. There are several modes. In some modes, like on pure natural gas, there is at top speed, there is significantly, not significantly, a portion of the top speed that gets degraded, like 5 to 15%, depending on the engine. So we say this is not a racing fuel. It could be. It's 130 octane. But the reason is, it's not that the fuel is not powerful, it's because it's a gas. And so it displaces oxygen. So if you have a limited space combustion chamber and you're putting in a gas, and then here comes another gas, which is air, well, you are displacing that air. If the combustion chambers are already maximized for that horsepower, meaning they're already squirting in as much fuel as they can produce with that size chamber, once we insert the natural gas, then that's where you get that degradation. Well, let's say for instance, an engine that has large combustion chambers for its power, so it's not fully optimized because they want to use the same block to go from 300 horsepower to 400, 2 years later. Well, it already has big chambers, and so in those conditions, it has no effect on the top speed. And I actually have one of those examples to show you today. But we also have another mode of operation, which I'll explain, where you combine 90% natural gas with 10% gasoline to eliminate that issue. And in that circumstance, then you have the same exact power, same exact speed, same exact acceleration as if you were with pure gasoline. Obviously, on the diesel side, we have that as well. We have projects with the Volvo, Penta, both on the gasoline and the diesel side. Caterpillar, Cummins, and that's an example of a Kohler generator down there, diesel generator. And we also work with other generator brands as well. There is a slight difference, technical difference, on how our system works for diesel. So on the gasoline, you can operate the boat in 3 modes: pure gasoline, pure natural gas, or the hybrid fuel, both combined. On the diesel, you can run them on pure diesel or hybrid, a diesel and natural gas mixture, where in that mode, 70% of the diesel is replaced by natural gas. You can also run them diesel engines on pure natural gas, but then the engine modifications make so that you can't use diesel because it becomes a spark ignited engine at that point. So we are actually implementing that for certain customers that are like, this is so good, I don't care about diesel anymore. We do short runs, we can put some natural gas on board, and we never have to worry about diesel. And by the way, these are pretty expensive engines, so let's just convert these to work on 100% natural gas. And so we use where the diesel injectors are, and we have some devices that go there, and we put sparks. Caterpillar does this all the time, and we know this because our head of engineering was the senior marine designer for Caterpillar in Peoria, Illinois. So they just use the same block, and they do the diesel, or they do the spark ignition, and they use a lot of those for generators. Yes, sir.
Now, this system won't work with the old two-stroke.
The answer is we can make it work. However, but 2-strokes gasoline?
Yeah, like the old IIMS.
Yes, it does. Yes. Now, two strokes gasoline, I can tell you, as it currently stands, no. And it would, if we had a large volume order, we can customize it for that. Everything that you hear here is customized. So we can definitely make it. But you know, emission standards are making 2-stroke gasoline engines be a thing of the past. They're already unlawful in certain states, the new ones. So this has been commercially available since 2015. The marine industry has embraced the technology with open arms. We have several manufacturers that carry our systems from factory. So if you want to order a boat, you just tell us what kind of boating you want to do, and we steer you towards one of those manufacturers, and so you can get the system already on the boat from factory. However, we also do a lot of retrofits, and no, you don't have to bring the boat to North Carolina. We'll take care of it at a marine service center where you do your boating. So we cater to both the professional user, the fleets, and the recreational folks. In 2015, the boating industry gave us the Top Product Award. And the same year, the International Boat Builders Exhibit, IBEX, gave us the Innovation Award. Just recently, a month and a half ago, in Europe, we won the METS show, the largest marine show there for boat building, the Environmental Initiative Award. These awards are great because they let people know that this technology is available now and it's clean. What people sometimes don't know is how affordable it becomes once you're running on it. So I'm going to take a little pause. Any questions so far? And then we're going to go right into the technology. Yes, sir.
But doesn't it require roughly twice the capacity?
Yes and no. It depends on which method we use. Do we use compressed gas? If we use compressed gas, then yes, it occupies more volume than gasoline to replace the same amount of fuel. But we have developed techniques where you don't need to replace the same amount of fuel. You can put less on board because, especially on a retrofit, you are occupying space on the boat. So you are displacing something, either a storage box or you're doing it under deck. So the answer is, when you put natural gas on those cases, the majority of the time you're extending your range by adding some amount of natural gas. And the amount is very specific to that boat's use, right? So what we have found is on retrofits, where the tanks displaced something, so the boat wasn't made with them on board, we put in anywhere from 15% of your original gasoline capacity worth of natural gas, up to 30%. We have no problem on most boats finding capacity to put that on board. The tanks using compressed natural gas are cylinders. We make them out of different technologies, so they can be very lightweight, made of carbon fiber, and they can be mounted vertically or horizontally. It's not liquid, so there's no sloshing. It doesn't really affect the maneuverability of the boat. If you have very large tanks, obviously it affects the center of gravity, so we need to make sure that they're centrally located on the boat. But so that's with compressed natural gas on a retrofitted boat. On a new boat, where the tanks are built into the hull as an integral part of the fueling system, we have a very good success at seeing 50-50, so 50% gasoline capacity, 50% natural gas capacity, and the reason is there are a whole lot more gasoline fueling stations, so you still want to keep your gasoline. If you take your boat where natural gas is not available, it's still operational, right? So much larger capacity on the boats made for it. Now, for the ships where we primarily use liquefied natural gas, then we have no problem finding space for that, because when you liquefy the gas, it actually reduces its size 3 times compared to the compressed form. So that means you can put less on board or less volume, but still have the same energy. Now, as far as the engine is concerned, there are no such thing as engines that burn the liquefied gas and engines that burn the compressed. The engines only burn the vapor. So compressed is already a vapor. You just decompress it, put it at a lower pressure, like 50 psi, goes onto an engine, and it burns it. On the liquefy, there's an extra device that we put there, which is a vaporizer. So it vaporizes the fuel on demand to create that vapor that the engines burn. So it's an extra step. So liquefied systems are more expensive, but they also are for users that consume thousands of gallons per month. So let's take a look at what this means on a gasoline boat. This boat was here on display at the Annapolis Boat Show, and we had it at the demo dock. So some of you have actually been able to go for rides during that show. So what is it that we add? You see, and I have 2 columns there. What's the difference between a hybrid natural gas boat, which is hybrid gasoline and natural gas, and dedicated just 100% natural gas? The difference is the gasoline tank does not exist on the other one. Our system comes from factory as a hybrid system with the ability to run on those 3 modes I told you. But if you have no gasoline tank, then we just disable the gasoline portion. The reason is the boat can start on any of those 3 modes, can crank on any of those 3 modes, so it doesn't really matter if you don't want gasoline. And we see that in certain touring customers. They're in a location, they have a tour boat, they go on a specific route, they don't take the boat anywhere else, and so they want the maximum capacity for natural gas, so they remove their gasoline tank and they become dedicated natural gas. The engine functions the same way. So what is it that we add? We add the BlueGas Marine electronic fuel injection module, which is a plug-and-play module. It's a computer, it's sensors, it's natural gas injectors, and port adapters. So there is no drilling, there's no permanent modifications to your engine. It's just an add-on, plug-and-play, bolt-on. So at any point, you sell the boat, or you sell the engine, or you repower, you can sell it with a system which adds value to your boat, or you can remove it, and in less than 15 minutes, you can remove the system from the engine. It is that quick. We went to great lengths, and this is all patented technology, because we went to great lengths to make it very user-friendly from an installation perspective. Because we really wanted the marine service centers to install this on the engine very, very quickly. So, and no thought process there. we're not converting. This is not a conversion. It can be. If it becomes dedicated, then you convert your engine into natural gas, but it's not a conversion, so it's just a hybrid system. Converting means taking away some ability, and we don't. You still have the original ability to run on the traditional fuel. So we add a control flow device. What this device does is it takes the gas from the storage tanks, which is compressed, and this control flow device keeps a constant flow to the engine at very low pressures. So 50 psi, 50 to 35 psi, so less than the pressure in a bicycle tire. So it makes it very safe to be on board. Also, because there is, unlike gasoline, there is no fuel on the lines unless the engine is running. So if you're doing maintenance and you rupture one of those natural gas lines going to the engine, so what? Nothing happens. You'll find out that you did that when you turn it on, because the system will start flashing at you and will not turn the natural gas on because it detects a loss of pressure. Safe. We add fuel gauges. Obviously, as you know, liquid fuels, you have your sender in your gasoline tank with the float sending a voltage signal to your gauge. Well, we do the same thing, but there's nothing to float on the compressed natural gas tank. So we just measure that pressure, and then we do some computer calculations. We add some computers on board, and the Helm computers, they translate that into the voltage to show you on your capacity gauge if the tanks are full or half empty. So you can have that. We have also created the signal to integrate with digital screens. So the same signal that goes into an analog needle capacity gauge can also be plugged into one of those more sophisticated ones where it's a digital dial that you see. So it's the same signal, it's just a voltage signal that goes there. Helm controls. So we add, and I'll show you the helm controls in more detail in the next slide, but we add helm controls. So you as the operator, you're able to switch the modes of operation at any speed from between any of the modes, and that no hiccups on the boat, seamless transition. And the reason is our computer starts changing the fuel on individual cylinders at a time. The technology in cars where if you're on idle, certain cars turn off certain cylinders, so you don't spend as much. Well, we use something similar. Not that we disable cylinders. What we do is we start, if you have a V6 with 6 cylinders, you'll have 2 cylinders working on gasoline if you're switching from gasoline to natural gas. Two already working on natural gas, while the other 4 are still working on gasoline. And then every half a second or so, they switch one by one. So very seamless transition. So you continue at maintaining your speed, and you don't have to get off a plane and things like that. And obviously we add the natural gas tanks. Here's an example of tanks on the boat that was here. Those tanks were actually built under an enclosure with some pretty blue LED lights, so people at boat shows could actually see them, because normally built from factory, they are under deck, so you don't get to see them. The first boat that we built, they were under deck, and people wouldn't believe that the boat ran on natural gas. So we were at the largest boat shows in the U.S., Miami, Fort Lauderdale, all those, and people would not believe that it ran on natural gas. So showboat, we put it, made it visible. Yes, sir.
What's the weight difference between?
The fuel is a third lighter for the same amount of energy, and the reason it's 130 octane. We take advantage of that extra octane. So on the engine, for those of you that are gearheads, we advance the combustion timing. So if you are operating in a mode that contains natural gas, either pure or combined with gasoline, we have advanced the timing. 130 octane, what it means is that the fuel releases energy during a longer period of time than the lower octane fuel, and that accounts for the much higher fuel efficiency. So as you can see from the performance charts in a minute, it does the same thing for less amount of fuel. Yes, sir.
The fuel tanks that you're putting in, built in, obviously, you're approved.
Yes, they're
Fuel
the
cell,
Department of Transportation certified. Yes.
what about Coast Guard?
There is no Coast Guard certifications to approve them. They abide by the certification by the Department of Transportation. And I can tell you that because as the leading company in gas-fueled ships, the Coast Guard recognized that they don't have much experience there, and they brought me into the Coast Guard steering committee, their advisory panel. And so I'm part of that advisory panel, and we're creating. The commandant is issuing some directives on standards for natural gas fueled boats, because the Coast Guard recognizes that for certain boats, T-boat regulations, documented and inspected boats, they need to send their inspectors out there, and they don't know anything about what are they going to inspect. So now they have a checklist of things to inspect, and most likely they're going to be inspecting one of our systems anyway, so they're already familiar with those. So Coast Guard regulations do apply, and so we are already working with the Coast Guard for the big ships, which are the regulated ones. The small ones are only regulated if they carry 7 passengers or more. So for those, we have a procedure to get the system approved before it gets installed.
As
Yes, sir.
surveyors, is there anything we have to look out for, anything special we should be looking out for?
No, you just need to looking for it. Give me some specific example. Either it's there or it's not there.
Deal with pressurized fuel.
That's correct. Yeah.
So, I mean, is there certain precautions, or certain things we should be safety valves?
Yeah, we install a lot of safety equipment on board. We did not start our system based on a legacy system that already existed. So we took the best of the different from the automotive side. We took it from the aircraft side. So we use all sorts of things, safety things that they use on aircrafts. Because if you think about it, an airplane goes out there, so a boat is out there as well. It's hard to get to, and you don't want it to fail while it's out there. So from stainless steel high pressure lines that are made out of stainless flexible braid versus on cars that they use rigid stainless steel lines. So we incorporate that. They're much safer. There's no leaks. But then we also installed a number of safety systems like airplanes have. And when they detect a loss of pressurization, they basically shut down the system. And because you still have gasoline on board, it shuts down. It continues to run on gasoline. Yes, sir.
Virtually all of the fuel components in marine have to pass a fire rating test. Have you guys passed the fire rating test for your tanks, your lines, all that stuff? Yeah, there's a lot of certification on those materials. I can tell you that the fuel lines are, yes, yeah, they're all certified. We don't manufacture the lines. What do we look at as surveyors? Because I mean, on
Yes.
gasoline, diesel, nowadays everything is A1 or it's got an SAE rating. Will these lines have some type of an SAE rating that we're going to look for, so that we know that somebody didn't just go to Home Depot and buy a piece of flex stainless,
Right.
put it in, and it's carrying
Right.
natural gas?
Yes, and it's very specifically written on the actual hoses. I don't have all of the technical answers for you, but if you send me some emails, we'll be able to answer your specific concerns. Yes, sir.
So what about, I guess when you turn the key off, obviously there's an electric check valve that shuts the pressure off. Feeding the LP gas to the motor.
It's not LP gas, it's natural gas. No, LP is propane. Yes, but yes. So there are all sorts of all the valves are electro valves, but all electro valves that we install are also manual valves in addition to this. So there's 2 valves. So yes, so you can actually shut off tanks and isolate them manually, and then the electro valves won't do anything. Yeah, yeah. And you'll see the boats marked because we put a triangle saying that it's CNG, blue triangle. So you know it's powered by natural gas. And on this particular boat, the triangle, I think it's either there or there. Normally we try to put it on the right side, the same as on land vehicles. Yes, Randy.
I think, answer to this question, that what you will find is a certification, the same certification that goes on accelerating tank, welding tank, because it's the same technology. And rather than reinvent the wheel several years ago, ABYC said we don't have to reinvent the wheel. All we have to do is apply the standard for UV resistance, pressure, degradation, flexibility, and it's already in place for outdoor welding tank. And I think that's what you got.
Thank you, Randy.
It makes a surveyor understand it better.
What's that?
It made me understand it better.
So here's an example of the helm control module. What you'll see here is a rocker switch and an analog gauge. So this is the natural gas fuel capacity. So it goes from empty to full, just like your traditional liquid fuels. And this rocker switch got some lights in it. You can run on compressed natural gas, or the middle mode is the auto mode or hybrid. 90% gasoline, natural gas, and 10% gasoline most of the time. And the pure gasoline mode at the bottom. If anything safety-wise happens, loss of pressure or a component malfunctions on the natural gas side, the computer automatically detects an error. It starts flashing there, so you know to take it to a marine service center, or some of our customers actually get certified on the BlueGas Marine system as a maintenance technician, because some are professionals and their fleets have their own technicians. So that's what how you switch between modes of operation. And of course, this is always completely integrated into the control system that comes with that engine. So you don't have a special throttle for natural gas. You keep using the same that you already have, and whatever gauges come from the manufacturer. Yes, sir.
Is there any thought of using the LPG?
The answer is yes. We explored our system. Essentially, generically, what it is, it's a management system for gaseous fuels. And that means we can manage natural gas, we can manage hydrogen, and we can manage LP or propane. In the United States, it is unlawful to put propane tanks under deck because propane is heavier than air. In the event of a leak, it pulls around just like your gasoline fumes, and it is very dangerous. So Coast Guard regulations do not allow propane under deck unless it's got a lot of venting mechanisms, right? So you see primarily propane bottles on boats, you know, on the rails and for grilling and things like that. So because of that, in the United States, we do not use propane. Now we do have some customers, I can tell you, that in Chile, where they have, we're just I was going to say, there's about 1,000 boats there that operate hundreds of miles of salmon farms. The majority of the salmon that you buy comes from Chile, the very southern tip of South America. So in those frigid waters, they have no natural gas lines taking the gas there, but they do have propane trucks that deliver it. And they're the same outboard engines running these small 115 horsepower Yamahas are running on propane with our system. Now in the US, that is not the case. So here's the fuel efficiency of a 21-footer Chris Craft with a Yamaha F250 horsepower engine. So this is a this is a single engine boat. What you can see, if you can see my the mouse pointer, the red line is your fuel efficiency under gasoline. The blue line is under pure natural gas. And then, as you would expect, the hybrid, the green line, is the mixture of the natural gas and gasoline. So let's talk about gasoline. So you start your engine, and as you start increasing speed, so speed here at the bottom, and then miles per gallon efficiency here on this axis, and of course your efficiency starts increasing until the boat is on plane and at most efficient planning mode. So on that boat, this differs from boat to boat. Even those powered with the same engine, 3.3 miles per gallon fuel efficiency, which is excellent to begin with on the gasoline side. However, once you flip that to natural gas and you run it on pure natural gas, you see that we can achieve 4.9. So it's a phenomenal increase in fuel efficiency. And this particular boat with this particular engine and this particular propeller, there is no speed degradation or power degradation on pure natural gas at its top speed. So all speeds top out at roughly 39.5, 40 miles per hour. As you can see, the other option, the advanced hybrid, the green, it's using primarily natural gas up to a certain point, and as it detects that your engine is about to start, I was going to say that wrong. This middle option was made out of a direct request from the Fort Lauderdale Cops, the Marine unit. They said to us they wanted to continue running on natural gas during the majority of the time, but they chase after gasoline-powered boats. So they wanted to have the same exact acceleration speed coming out of the hole, and they also wanted to have the same top speed. So that's what we developed this advanced hybrid mode for, because most people are not racing or in racing conditions, and you can run on pure natural gas, and why not take advantage of the cheaper, cleaner option. So for them, this is how this works. Mostly natural gas, so as you can see, it's closer to the natural gas fuel efficiency line, and up to this optimum point, small whiff of gasoline there, and then past the optimum point, if they want to have the same acceleration of gasoline, then it starts using the proportion of natural gas to gasoline. It starts shifting, and the computer does all the calculations. It senses engine load requirements, and at higher RPMs, it's not the RPMs, it's the load factor, and then it gives it more or less gasoline depending on where you are with this. So, yes, sir.
These charts, that previous chart was in BTU equivalent for a gallon of gasoline?
Yeah, so the federal government created a unit for natural gas to be dispensed as a fuel, and that unit is this right here. It is the gasoline gallon equivalent.
Right.
There is also a diesel gallon equivalent, so it's GGE or DGE. That is the federal government's unit. So when you go to a public gas station, you take your boat there and you fill up, you are buying fuel in gasoline gallon equivalents, and that's what you're paying. So you don't have to do any math of, is it BTU equivalent, is it not, this and that. So although it's an energetic comparison, because the fuel is 130 octane, we get that better efficiency with the same energy content, because of the engine advancing time. So this is the fuel consumption for the three fuel modes. As you can see, gasoline starts increasing its fuel consumption past that optimum point around this area, and then it just spikes as you would expect. So at top wide open throttle, 17.2 gallons per hour. And you see the natural gas at the same speed is 10 gallons per hour. So a whole lot less fuel being used for the same speed. And as you would expect, there's the advanced hybrid is always in between those two. So let's talk about diesels. As of October, we rolled out our same technology for diesel engines. And we, this is an example of a project we're currently doing to put our system on 15 brand new ferry boats. These boats will be used to carry 300 passengers. So the shape and organization of the content of the ship is now in design mode. But they're fast-speed coastal catamarans used for commuting passengers, and so these particular ones will not transport cars, and they'll transport roughly 250 to 400 passengers. So in the bottom, I actually I'll explain this table in a minute, but it explains the options available for a diesel ship as far as natural gas options. So I'll start explaining. Diesel plus compressed natural gas. So that's your hybrid that I explained earlier. You can continue to run on diesel, pure diesel, or you switch to the other mode, which is the diesel natural gas hybrid. That's where 70% of the diesel gets replaced on average with natural gas. So that's where your great savings start showing up in terms of fuel utilization, but you still keep your diesel intact. The engine internals are not changed. So basically our system there is also an add-on to the engine and all of the other modules we add to deliver the fuel to the engine. The other mode is the pure compressed natural gas. In that mode, you cannot change to diesel. And on that mode, we actually take engines from certain manufacturers like Caterpillar and Cummins and some other manufacturers, and we turn those large capacity engines into, sometimes they already come to us as spark ignited engines, and we either marinize those, and then we get the EPA certificate of compliance. And so we install them on those ships as pure spark ignited natural gas engines. So that's the other option. That's still using compressed natural gas. And then there's the same two options from the top, but now using liquefied natural gas. That gives you more range, but they're also slightly more expensive. So let's take a look at the price. So if you go with diesel plus CNG, the cost for equipping this boat is roughly 300 grand. With the LNG, the diesel plus LNG is costs roughly 70 grand more, 60 grand more. And then CNG, pure CNG, there's actually more expensive than pure LNG. And look at the payback, 9 months for this one. So this was the first batch of ships, a batch of 5 ships for this particular customer are being produced with this system. Let's take a look at the fuel savings per year per boat, almost 400 grand. So, and that's the consumption per hour of combined diesel plus natural gas for that particular. So you can see consumption goes down with running with primarily natural gas, but the system is also more expensive. So here's the fuel savings for 5 ships running primarily at 25 knots for 5 years. It's significant. So 8 to 9 million is your range. And in terms of diesel, the same amount of diesel that they would use without using any of our technical options is 24 million over a period of 5 years. So significant savings, a system that pays for itself in less than a year. Yes, sir. Say that again. Yes. So let me explain to for instance, for that customer. For that customer with the 5 ships, they have 2 options. Initially, they're bringing in tractor trailers with compressed natural gas, and it just dispenses onto the boat actually faster than diesel would, because there is a pressurized fuel, so that pressure on the empty tanks just wants to equalize, and so very fast. So mobile with the truck, and the cost there is that particular customer is in Europe, and they're paying. I can't remember now. All of this is translated into dollars for the prices that they pay over there. But here in the United States, they save about half. Half is the savings, half on the price of the fuel, and then of course the fuel is more efficient. So I have on this chart here, the largest truck on land consumes 13,000 gallons of fuel per year. Those are your tractor trailers, 18-wheelers. Look at our 3,000 passenger cruise ships, 22 million per year. So BlueGas Marine currently makes systems for these ferries, 50 cars or 300 passengers and going down. So we call them the brown water, not that they're all brown water, but the brown water diesels. So tugboats, those that push barges, motorized barges, any other diesel ships, recreational or for use in recreational or commercial operations. The payback, I'll give you an example of a inspected and documented and inspected customer, water taxi, 5 months payback. They were using 12,000 gallons a year of gasoline on their 2 outboard engines there on the back. With the extra efficiency of natural gas, they're just now only using 8,400 gasoline gallon equivalent, and the cost is half. That's the retail cost at the station. In their particular case, we put in a small scalable station. So as they have more boats running on natural gas, the amount of storage on land for that station increases. There's a pipeline that comes from the utility company, just like the one that goes to your house. It's one with similar pressure, and then there's compressors there that store that at higher pressure inside the land tanks. The BGM system cost for their boat was less than $14,000, and their fleet of 10 boats gets $312,000 in annual savings. And it only costs 150 grand to make one of those boats. So every year they're affording to expand their fleet by 2 boats just on savings if they wanted to do that. Same thing for similar thing for police and some ferry boats in the U.S. Just some phenomenal savings there. Similar price system for the amount of capacity they have on board, and different payback because the cops patrolling use 6,500 gallons on these 29-foot Intrepid boats with the twin Yamaha F250s, and then this Clearwater ferry in Florida, it uses more. So the more fuel you use, the faster your payback. Obviously, the system costs the same, less maintenance, eco-friendly, all that good stuff for both of them. So there's examples of customers from houseboats with generators to first responders. Go Boats US and Cito started rolling out our system now for their boats. Obviously, diving and charting operations, and very easy to put this thing on pontoons. There's no deck to cut or anything like that. You just put the tank under a seat. Very, very easy. Yes.
However, capacity state, some of these guys do carry about 40 gallons of diesel.
Yeah, that's a very per boat situation. So let me give you an example. 90 foot car ferry that does river crossings in Michigan that we're doing right now, they just decided to put in a 2,000 gallon tank equivalent, but yet they're carrying 10,000 of diesel. So what they're doing is they're filling up every 2 or 3 days during low periods, once a week with the natural gas, and they purchased a station. By the way, the federal government gives 50 cents for every gallon that you buy or use if you own that station. So they're basically, I told you, they're buying gas at 25 cents. So they're getting the federal government is paying for their fuel and their operation to compress and dispense that fuel. Also, up to 30% of the station gets paid for federal dollars, and then certain states also kick in some more. So the feds are not saying don't use diesel anymore, but what they're saying is there's an American gas fuel that is creating jobs here at home and cleaner for the environment and cheaper. So use it here. We'll help you with the initial costs by doing that. So we're also getting into the obviously law enforcement and military uses, because our system gives our military stealth capability on being able to be traced on the water.
When you went back to that Coast Guard.
Yes, sir.
The Coast Guard boat carries 300 gallons of fuel. Of regular gasoline.
Yeah.
How will you substitute CNG in that same space or storage capacity to support your CNG system?
Okay, very good. So let's say that it is a retrofit. If it is a retrofit, we would put in 20 to 30% of those 300 gallons. So we were talking about 60 to 90 gallons, gasoline gallon equivalent. If it's a retrofit, we can find space for those tanks on board. If it is made from scratch, so like Metal Shark that makes the Defender class boats, makes it from scratch, then we can put in 60% of that capacity worth of natural gas, and then the rest being the gasoline backup. And here's the interesting part. The majority of the Coast Guard bases has the natural gas already piped in for heating and cooking. So they could be fueling up there to start with. Yes, sir.
Question, could you back up to that, I guess the third slide back to the truck, the road truck?
Yeah.
Why is the conversion on a road truck so much money?
That's an interesting question. There's not one company that does the entire thing. The reason is Cummins and Agility are the two companies that are combined to do this on trucks. You have a number of other brands, but it is so much more because Cummins has a special purpose engine developed from scratch. So the price is higher than a regular engine with, so they go about it differently, right? So they made a specific engine for that. And then Agility makes all the dumb components for the rest of the system up to the engine. So it's two companies, you know, they have to work together to make an entire system. Here, we were able to bring down the price because one, it's not a specific engine, it's an add-on. So we don't have all those costs of building a new engine. So add-on top there, and we're one company doing all of this. So we're able to get volume. What's that, sir?
Is that a hybrid or a full CNG engine?
On the truck? On the truck is, you can get both. Yes.
Your very next slide.
Yeah.
If you go to that, why the difference between the CNG price, 40 cents GGE equivalent, and $2? Yeah.
So this is the police, which is a municipality, municipal entity. So they buy gasoline at whole price, wholesale or close to wholesale, and they're able to do the same thing with natural gas because the city is the utility. So they're able to get that. So I wanted to give you an example. Obviously, this is somebody, a customer that is buying gasoline at retail prices, and it's buying natural gas at retail prices. So there's the price disparity at retail, and there's a customer, municipal customer, and that's the prices that they get it at.
So if these motors running hotter, it's fuel,
Cooler,
you're running cooler,
yes, sir.
so your life expectancy of your motors goes from 5,000 hours to
Longer, yeah. Yes, Randy. As I explained to you, our business model is we manufacture the systems, we deal with the customers directly. However, once it's time for installation, we'll take you to a marine service center that is certified on doing the maintenance and the installation for that boat in that area. So for instance, here we have folks in Annapolis that can do that. And we partner with the marine service centers that are factory authorized in those engine brands. So if somebody's factory authorized in Yamaha engines and Suzuki engines, and they do factory warranty claims for those engines, those are the ones that we partner with. So if there's ever a problem warranty-wise, they know they can send the claim to Yamaha. If it's a problem on the mechanics, they can send the claim to us. If it's a computer problem in our system, and they can do that right there. No painful experience for the customer. If it is just a certified technician, they have to use a third party. Third party knows nothing about our system, and it's a headache. So that's what we do. However, for the diesel, the maintenance is also done on the local area. So we train technicians there, but the installations are done by our team. So that's the difference between gasoline and diesel. Our team does the installations. Those are usually at a shipyard, and so we send our team there. And then at those locations, we have them do the maintenance. So here's the different examples of how you can fuel in a compressed natural gas boat. First one, there's 3,000 public stations on land. If your boat is trailerable, like that top left corner, you can just take it there and fill it up. We do so all the time when we take our boats throughout the country. I've seen prices range from $1.80 to $1.20, and out west, 65 cents, because the states are sponsoring the fuel as well. They are producing states. Home station, or $6,000. So you already have the pipe coming in with the natural gas. Put one in, $6,000, fill up your boat overnight. No storage of fuel on land. It uses the tanks on board your boat as the storage. So it gets it from the line, compresses it, puts it on your tanks. It takes a few hours to do that because it has no storage on land. Mobile station, it's a trailer pulled by a small utility vehicle like a F-150 Ford pickup truck or equivalent. Public CNG dock at the marina where you can get the gas next to where you can get your other fuel. So opportunities for you as surveyors and as professionals in the marine industry. If you introduce customers to us and designers to incorporate our cleaner and technology that makes boats more affordable, there are referral fees that you can earn. Also, if you are really enthusiastic about this and want to take drive this into the marine industry, then you can become our commission-only salesperson and earn commissions on sale of systems and also the fuel stations. So I have given all of you a brochure. On the back of the brochure, there's an examples of our system being installed and my business card. If you do not have one, please come to me, and I have them here. Also, go to our website and take a look at the articles and videos that are there. You can point customers there as well. The diesel projects are going to be added to the website. There's currently no diesel projects on the website because it's a new product that we rolled out, but it's there. And I'm always happy to talk to you over the phone or email, and really appreciate your smart questions. Thank you, guys.
I would like to ask you if you would engage the opportunity to write an article for our report.
Oh, yeah.